3 x plus 2. That replaces that bottom piece there. Now you never divide. You always multiply by the reciprocal. So this becomes 5 over x plus 2 times x minus 3, x plus 2 over 6. And then do you see any cancellations? Anything that's the same in the top and the bottom?
The x plus 2.
So those do cancel, and you're left with 5 times x minus 3 over 6. You typically leave it in this factored form. Let me know when you get that down, Josh, and we'll proceed to number 31.
Hey, there we go. All right. All right. Did you hear me?
Yes.
Okay.
Are you ready?
Yep.
Okay. So this one's adding. Adding's different than dividing. You have to make a common denominator. So your common denominator is going to be the product of the bottoms. So you multiply the top and bottom by the one that you're missing. Okay. So the net result here is the bottom is x plus 4, x minus 3. And you have this 3 times x minus 3 plus 4 times x plus 4, like that.
Okay. Get that down here. All right.
Let me know when you're caught up. There's still more to do.
Okay. I have everything down so far.
So you multiply in on both of these. You get 3x minus 9 plus 4x plus 16. And then you do simplify. So you combine like terms there. And in this case, you actually can factor yet again. You can make this factor out of 7. This is all for the top, by the way, the numerator. The bottom stays the same. It stays as x plus 4 over x minus 3. So the final answer is what's here in blue, in the blue box.
Okay.
Everything else just sort of work to get there.
Let me get this down.
And then when you get all that down, we'll move to 32.
Okay. All right. There. I have everything down.
So this problem here, you're reducing roots. We're going to reduce first the square root of 12. So to do that, you start with 2. You start with prime numbers, 2, 3, 5, and so on. 2 times what number gets you back to 12?
6.
6, and then you try 2 again. And so for any pairs, you bring that out. So you bring the 2 out, the 3 stays in, so it becomes 2 square root of 3.
Right. Okay.
For square root of 27, it's kind of the same deal here. 3 and 9, 3 and 3. For each pair you circle, you bring it out, bring a 3 out, 3 stays in, but there's already a 2 on the outside. So that 2 pairs with the 3, square root of what's on the inside, which is a 3.
Right.
So this becomes 6 square root of 3. So if we were to sort of like we did all this work off to the side here, which really it is part of the problem, but the net result is that this becomes 2 square root of 3. This becomes 6 square root of 3. They're both square root of 3s. So you can add them together. What does that become?
That would
8.
be, oh yeah.
8 square root of 3.
Let me get
Yeah,
down
let me know
here.
if you need me to scroll up at all.
Let's see. Okay.
Got it?
Mhm.
Okay. Next one here, slightly different strategy here. But we're gonna multiply what's underneath the roots times each other. So 3x times 9x to the fourth, that becomes 27x to the fifth.
Okay.
Okay. And then from here, you're taking the cube root of that. So we're gonna talk about how to do that. It's the cube root of 27. And then you're also going to do the cube root of x to the fifth.
Get that down. Okay.
All right, you got that down?
Yep.
Okay, so now 27 you break apart just the same way we did before, but this time you're looking for triplets,
Okay.
pairs, triplets. So
Mhm.
for each triplet you bring one out. Now there's nothing left over, so that becomes just 3. Like the cube root of 27 is just 3.
Mhm.
Now this x to the fifth, if you kind of follow the convention we've been doing, you would write something like this, which kind of seems crazy, but that is kind of what you're doing. You have a triplet of x's, so you bring an x out.
Okay. And would we have another X?
These are
Yeah, the
inside, these left in. So it becomes the cube, you got x on the outside, cube root of x squared, and that's 3 pairs with it, which
we
so it
get all
becomes
that down.
3x cube root of x squared.
Okay. 3.
Sorry, let
Okay.
me know when you get that down. We'll move on to the next one.
Okay. I got everything
Okay.
down.
All right, so this one's kind of worse. So we're actually gonna bring what's outside to the inside like this. And we did some problems like this earlier. It's really in a previous lesson. It's really just like 12 over 6. You know, we made this kind of this table, x cubed over x to the seventh. Maybe you remember doing that.
Right,
The
right.
12 over 6 is a 2, so that goes up top. And then x cubed over x to the seventh. Do you remember anything about what that becomes?
I would, oh, we would, I think, subtract.
Subtract the exponents.
Right. I think that would be
So,
negative x negative 4.
yeah, now we bring it back down to the bottom because
Mhm.
we want it to be positive, and this is what you're left with.
Okay. Get that down.
But wait, there's more.
And, yeah. All right.
All right, so the last thing here is you now take the fourth root of the top and then the fourth root of the bottom without getting into y. When the index matches the exponent, it cancels completely. Uh, so the answer here is the fourth root of 2 divided by x. It's actually the absolute value of x, but I don't know if your teacher will want that. They might think it's weird. So just go with x
Okay.
to avoid any suspicion of assistance. All right. Any questions, thoughts on that before we move to 35?
Ooh. Okay. I guess this was just you break down everything.
Yeah, I mean, sometimes you like combine them, then you simplify, then you break it apart again.
Right. Okay. That is okay. All right. Put everything down.
Okay, so last problem here. This one's a kind of again like you'd have to be told what to do. You would never know to do this. You multiply by what's called the conjugate on the top and the bottom there. The conjugate is, sorry, I messed this up. It's plus. Can't see it. You switch signs.
Okay. Um,
Okay. So to do this, it's 9 times x plus the square root of 7 on top. On the bottom, you have to FOIL this. Okay. FOIL here. So FOIL first times the first. We'll do it together here. What is x times x?
x squared.
X squared. Now x times the last one, square root of 7, is x squared 7. You just merge them together. The inner is negative square root of 7 times x minus x squared of 7. And then the last is minus square root of 7 times positive square root of 7 minus square root of
49. Okay.
49.
All right. I'm gonna get that down.
Okay, so the O and the I's cancel, which is pretty common here. Square root of 49 is 7, becomes x squared minus 7 on the bottom.
All right.
So now the top is still the same. It's 9 over x plus square root of 7, x squared minus 7, and that's your final answer.
Okay. Okay. Well, all right.
All right, let me
Oof.
know we can move on to the next one here. Let me know when we can move on to number 1.
Okay, we can have everything down.
Excellent. All right. Number 1 here. Which type of equation has no solution? I mean, this is pretty broad. The thing that first came to mind are um, equations that are parallel. I actually have no idea what they're asking for here. Um, it has no solution if the variables go away. So
Right,
and they might be just looking for a word here, like if it's inconsistent, it has no solution. I really have no idea what it's looking for, Josh, to be like as direct as I can be. Sometimes I don't know what the
right.
looking for.
Could be parallel, but
Well, that's if it's two equations. This only says one equation.
right. Mm, okay.
Okay.
Well,
Number 2, probably kind of the same type of situation here. What if it has an infinite number of solutions? It's always true. Um, and that is typically dependent. But again, I'm not sure what they're referring to. So what I was going to do is slide like this line on top of the other, and that's what it means by always true. Like they're always intersecting.
right. Makes sense. Sure.
Number two, number 2 here.
Yep.
All right, so to clear the equation of fractions, what value would be multiplied across the entire equation? What you do is you look at the bottoms of both equations, whatever fractions you see. So see how there's a 2 on the bottom and there's a 5? You
Mhm.
look for what's called the least common multiple. So you basically go up until you find the least common multiple of both. Could you attempt to tell me what that is, please?
Multiple. I would say five. I feel
It
like I'm
has to be
wrong.
in both lists.
Or both lists. Okay. These common multiples of 8, 2, 4, 6, 8, 10.
Yes, 10.
Oh, 10.
That's the correct answer.
Interesting. To clear the equation. Huh, okay. Grab something. Here we go.
All right, so let me, I'm gonna graph this so you can see what you've got here. Okay, let me know when you're there, ready to go.
Okay.
Okay, the first one is the square root of, I'm sorry, absolute value of x plus 3. That's this V graph here. And y equals -10 is down here, not to scale. So
Okay.
my question to you is do these intersect?
X and the Y. Um,
Do these lines ever hit each other, cross, touch?
you said the X was the line going down.
This
Oh,
V is absolute value of x plus 3. Y equals -10 is this line here. Do they
no,
ever
they don't.
intersect? No. These have zero solutions. Solutions refers to intersections.
Okay.
Okay. Um,
Okay.
Number 5.
Hmm?
Okay, so a few things about variables here. So the input is x, the output is y. Y depends on x is independent.
Okay.
Does that make sense now? Um, to get a y, you need an x.
Right.
So
Okay.
the dependent variable is the one that requires something for it. So which is the dependent variable in this?
The Y.
Yes. Okay.
Okay.
Okay. All right, here we go. Um, Great shape here time-wise. All right. So in this equation here, you look at the side with the variable,
Hmm.
which is the left side. And you say, how do I undo stuff to get the variable by itself? How do you undo this negative or traction by 10?
We would have to um plus. We use addition.
You're going to add 10 to both sides. So what does y equals?
Y would equal 25.
Very good.
Okay. What's okay.
Okay. All right. So you again look at the side with the variable. You have multiplication by 3 and addition of 14. You always undo addition and subtraction before multiplication and division.
All right. We would subtract by 14.
Agreed? So that gives you 3w equals what number?
That would be, yeah, so that would be -15.
Good. and then you divide both sides by 3. What does W equal?
W would equal -5.
You are correct.
Let me get that down. Okay.
Next problem here. So the problem here is you have decimals. So if your biggest decimal is 1 decimal place, you would multiply by 10. If your biggest decimal is 2 decimal places, you multiply by 100. How many decimal places do you have in each of these positions?
I have sorry, my mom. Let's
Okay.
see what I was doing. Uh
So like
we have
point
one
five is
there.
1 decimal place,
Yeah, we have one there and then two, and then I'm gonna say one.
but there's 2 digits to the right of the decimal.
Okay, so it'd be two.
Yes. So that tells you you're going to multiply the whole thing by 100. You're going to multiply everything by 100. And what that does is it should eliminate the decimals.
Right.
Now, if you're ever unsure, you should use a calculator. You shouldn't, eyeball it or, go with what feels good or, like you should be like, okay, you know, let me make sure I got it. So this first one is the one that a lot of students would mess up.
Okay. So write this down. Three. Okay.
All right, so could you try solving this? It's basically like the previous problem we did.
Yes. Um, 73x equals 173.
You cannot combine these, and that's not what we did in the previous problem. What did we undo first in the previous problem?
Oh, all right. We subtracted
Okay,
by 23.
so do the same thing here.
23. Okay. 50, 50, and 150. Okay. I have 50, x equals 150. What did we do for the last one? Then I think we did some division, right? Yeah, we
Well,
did division.
look back at your paper. And so if it was unclear, you want to say, hey, Matthew, I don't understand that step. Yes, there is division.
But I think we would divide by 50.
Yes. So
Then
what
that'd
does
be
X equal?
3.
Okay, good. All right, so get all that down.
Okay.
Why is it not snipping? And well, there it is. Okay, you ready, number 9?
Mhm.
Okay, so this is called a literal equation. It has no numerical result, which could be uncomfortable, odd, unfamiliar, all those
Mhm.
things. Um, Sometimes that happens in these. So um, we're still solving for x. That's still doable. We're going to first add 5 to both sides of the equation, and there's nothing that you can combine it with. So you you just leave it off to the side, 3w plus 5. So go ahead and take a look at that, maybe get that down.
Okay.
Now, you see that on the left there, there's an x in both terms.
Hmm.
So we're going to factor that x out. You're basically dividing both of those by x. What is left over? What would go in parentheses?
Q and R.
Okay, q minus r.
Q minus R. Um, R. Okay.
And then now
Oh,
we're going to divide both sides by q minus r. And, that doesn't look great, but that is your final answer.
E. Okay.
All right, any questions on that?
Mm,
You don't have to have questions. I just throwing that out there.
I don't think so.
Okay. All right. All right. Last one on the set here. So absolute value equations, you end up solving two different equations. Okay.
Mhm.
You end up solving the equation as is without the absolute value. So you can see it's exactly like this without the absolute value. And then secondly, you just change the right-hand side to the negative.
Okay.
All
Just
right.
hit
Now
the
to solve this, you have to do like we've been doing in those earlier problems, like number 7 and number 8. You have to undo addition and subtraction before multiplication and division. So I'd like you to try solving each of these, please.
Okay. Oh, just looking at this, mm, okay. So I have x, 2x equals 16 for the left, and then for the
Yeah,
right,
but keep
2x.
going. That's not the final answer, right? Like you gotta divide by 2.
Oh, wait, divided by 2. Oh, yep, okay. So I have x equals 8 for the left, And I don't know if I can do, I don't know if I can divide 2 by 2 for the right.
You can.
Can.
What is a number divided by itself?
That would be 1.
Yeah.
1, yeah.
Okay.
So I
There you
do
go.
the
There's
1.
your two solutions.
Two. This one. Okay. All right. I I guess since we don't have anything, we can do either we can if you want to end, but we can maybe do problems you think that would be like a good review, maybe.
Yeah. Let me give you a few more to solve here. Let's go like 5x minus 1 equals negative 21. Let's just have you
Okay.
solve that.
The one. X would equal -4.
Correct. Very good. All right. So let's look at some of those root problems and say a 3 square root of 8 plus the square root of 50. This is one like we did earlier. You have to be able to reduce each of these roots. So I'd like you to try the square root of 8. See if you can look back at what you did on one of those earlier problems if you're not sure how to proceed.
Mhm. Maybe- Okay, that would be 2 and 4 and 2. Oh, and we do I do them for both?
Well, tell me what you got for the square root of 8.
I got 2 on the out and then 2 in.
2 square root of 2. Now you bring this 3 down and you multiply. So what's the final result there?
Would be 6 on the outside and 2 on the inside.
6 square root 2. Good. So now do the same thing for 50.
Okay. Okay. Different one. Okay. So let's see the keeps inside. They don't match.
The square root of 50 does reduce.
Right. Okay. Unless I switch these things. Okay. Okay. I'll have five, five, and two on sides of five, two, five, two, and then so I have five and two.
5 square root 2. Now,
Two.
why are you allowed to combine these? What's the key thing here?
I guess we have an addition sign.
Well, it's more than that. It's that they both have a root 2.
Okay. Sense.
So what does this become?
That would become 11 square root of 2.
Yes. Yes, very good. Okay, let's try another one of these solving equations. Solve px minus w equals 4 for x. So notice that x is here. You kind of want to think about p and w as just being numbers, even though they're not.
Hmm.
But it's like, how do you undo subtraction? How do you
Addition.
undo yeah, so you're going to add w to both sides, for example, here.
That would be px equals 4w. Think so.
Yep. No, 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 you're adding. You're adding. They are not combinable.
Oh, okay. That would just be 4?
You're
No.
you can't combine them. They're just
Oh,
there.
4 plus w. Okay. And then we would subtract. No, we would divide. We
Divide
divide
by p.
2 over p. Again, we get x equals, I don't know how would p divide,
You
but
just leave it. That's the whole point of these, is you're not actually doing anything. You're just
okay.
getting. It's something on the right where. mm, uh,
Okay. Okay. All right.
Okay. So let's try another one here. Uh, pi 2 pi RH minus a equals 5. We want to solve for 8. There's 8.
So 2 pi RH. Okay, we would plus a to both sides. And then we would get 2 pi RH equals 5 plus a. Then we would subtract by 2. No, divide by 2.
What did you undo first?
Oh, I undid the minus a, like
Okay,
plus a by both sides.
all right, so this is 5 plus a, and then
Mhm.
you divide by everything in front of h.
Okay.
So 2 pi r, 2 pi r.
And I guess that equals h equals 5 plus a 2 pi r
That's your
over 2
answer.
pi. What?
Yes, that's it.
Okay.
That's your final answer. Okay, we're gonna stop here for today. Good job. We got everything done and then some. Always a